So I have an ambulance going down the highway and it's moving at 31.9 meters per second. If the siren has a pitch of 1243, what is the difference in pitch you observe as the ambulance comes towards you versus the pitch you observe as it heads away? And take the speed of sound to be 331 meters per second. All right, so this is the Doppler shift with you sitting still. And so the first frequency you hear, and I'm going to just go ahead instead of saying F observer, I'm going to say F1, the first frequency you hear, is going to be Fs, the frequency of the source, times velocity of sound. Well, and you're not moving, so it's just velocity of sound. And it's headed towards you, right? It's headed towards you, so a minus sign. And so we have the equation for the first frequency. All right, the second frequency that you hear, the one when it's moving away from you, well, again, we have velocity of sound, but now we have velocity of sound plus the velocity of the source, because now it's moving away from you. And what we're asked for is what is the difference in pitch, right? F1 minus F2. What is the difference in pitch? So let's take all the data that we have. Let's go over here and calculate those two and get the difference. So we know the frequency of the source is 1243. We know the velocity of the source is 31.9. We know the velocity of sound is 331. And so F1, let's get that. Frequency of the source times the velocity of sound divided by the velocity of sound minus the velocity of the source gets us 1375. F2 is going to be the frequency of the source times the velocity of sound divided by, and now in this case, it's the velocity of sound plus the velocity of the source. And now you have it. And now delta F, right, is F1 minus F2, and we get 241.8 hertz is the difference in pitch from it coming towards you to it going away. All right, that's it for this problem.